All right, so just to give you something real quick to do on this National Testing Day, I wanted to go through a few examples that I saw on AP Classroom where they ask you to do a cross-sectional volume, but it's asking you to work with one that's run perpendicular to the y-axis. So you'll see in the way it's written, everything that we did in class and everything you had to do for homework was slicing it perpendicular to the x-axis, which means everything needs to be in terms of x's. So if they ask you to do it in terms of the y-axis, it is not much different. The biggest thing to realize is your variables just all have to switch. So this is one, it was on a calculator section of an AP test pretty recently, actually. It only had 4 choices, so it's been in the last 5 years. So they actually give you a picture, x squared, which is this one, and 2x, which is this one. And we are slicing it into squares, so we have no coefficient, and the side length will be this length. So the squares will be running like this. When you have it anything perpendicular to the y-axis and you have to represent your length of your side or diameter, whatever shape it is, everything has to be in terms of y's. So instead of y equals x squared, I want to write this as x equals the square root of y. Instead of y equals 2x, I want to write this as x equals y divided by 2. My boundaries, my slicing, will be from the low y to the high y, which you can actually see on this picture is 0 to 4. If you couldn't see on the picture, you could graph it on your calculator if you needed to. You have no coefficient because it is being sliced into squares. To find the length of that side, instead of doing top minus bottom like we do with x's, you're going to do right minus left. So it's going to be the square root of y, which is the rightmost function, minus y over 2. That whole thing is the length, and it does need to be squared. So this would be your setup of your problem. Since we're allowed to use a calculator, we're going to grab our calculator. We're going to go to Math 9. We're going to go from 0 to 4. In parentheses, the square root, I'm going to type it in as if it's an x, even though we know we're working with y's, minus x over 2. Close your parentheses. Don't forget to square it. Don't forget to put the x at the end. And really let the calculator do the work for you. So this 1.533, which means my answer is B. Let me show you another one that has the same setup just so you get to practice it another time. So same idea. They gave you a picture. This is a calculator problem. This time this function is y equals x cubed, and this function is y equals 4x. So we have our line and our cubic. We are still slicing it into squares, so still no coefficient. We are going perpendicular to the y-axis. One thing I've noticed, because I haven't found a lot of these questions, when they ask you to go perpendicular to the y-axis, they tend to keep the rest of it very simple, meaning we're slicing it into squares. We're working with pretty simple functions. So I need to write these in terms of y, so that's going to be the cube root of y, and this one is going to be y divided by 4. So the length of the side of my square is going to run like that, run perpendicular to the y-axis. So my boundaries are 0 and 8, and I can tell that just from looking at the scale and seeing where they intersect. If you couldn't tell that, you could also either set them equal by hand or you could grab a calculator. My side length is going to be right minus left, so it's going to be the cube root of y minus y over 4. That whole thing is squared. Again, I'm going to grab my calculator. I'm going to go to Math 9, going from 0 to 8. Parentheses, the cube root button, or you could do the 1/3 power. The cube root button is in the math menu. I'm going to use that, but you could do the 1/3 power instead if you're having trouble finding it. So the cube root minus x divided by 4. Make sure you remember to square the entire length. Make sure you put the x at the end. You are going to get a decimal, obviously, looking at the choices. And you get 2.438, which again is B. I wonder if these two questions were back-to-back years because they are so incredibly similar. They wouldn't put 2 questions in the same year. So my guess is one of these was 1 year and one of these was either the next year or a year later. Excuse me. I want to show you one other question that's more of a setup question. A little different than what we did in class, but just kind of show you how to deal with it. This one actually is the exact same region that we looked at in the first problem, so x squared and 2x. So we already had that picture. I can go back and show you the picture again. We are going perpendicular to the y-axis again, so we do need to be in terms of y's, so that doesn't change. The difference is now instead of squares, we're going to make it be rectangles where the height is 3. So we never did rectangles in class, but the idea is the area of a rectangle It's just length times width, or base times height. So with a square, we take the side length and square it, because that's how we find the area of a square. With a rectangle, we're going to multiply the dimensions. Well, they already told us that one of the dimensions is 3. So we can replace one of these dimensions, doesn't matter which one, it's a rectangle, with a 3. So that I'm going to be integrating that. Everything that I did back 2 questions ago is still going to hold true as far as boundaries. So let me go back and show you that picture. So this is the picture they're referring to. So we know we're going from 0 to 4 because we're in terms of y's, because we're going perpendicular to the y-axis. And we know that this was the side of my square, and we did right minus left, which was the square root of y minus y over 2. Well, now, so we know we're going from 0 to 4, and the nice thing about that is that gets rid of C and D, because A and B are the only ones that are the right boundaries. What you are doing with this now is you are taking your right minus left. So your right minus left is going to be the square root of y minus y over 2. You are still, let's see, your height is 3 times the 3 times the base. So I guess I should have wrote this as, I didn't write it right. I should have wrote it as 3w times w. So one of your dimensions is 3 times bigger than the other dimension. So rather than do L and W, I'm just going to say they're both W. Get rid of that. So one of my dimensions is 3 times the other. So I am going to have a 3 out front, but I'm still going to be taking that dimension times itself. So whatever that width is, or height, or side, or whatever you want to call it, you're still taking that and squaring it. So you still have all of this squared. So again, right minus left, that's where we get the square root of y minus y over 2. The reason this one has a 3 in front is we're saying that the height is 3 times as big as the base. So if we call the base w, then the height would be 3w, or if we call the base x, then the height would be 3x. My boundaries are 0 to 4, so that eliminates 2 of the options, and then we set it up only. So my answer is A. So there are 3 examples of ones that ask you to work in terms of y's, ones that are very calculator driven, and ones that are only set up at all. These are not very common. I searched through probably 50 different questions on AP tests, and these were the only 3 good Y problems I could come up with. So do not expect it to be a really common question on an AP test.